Professor Dr. Saravanan, experienced professor in the field of diesel exploration. Recently, I got his contact through the faculty development program in Atal. Last year, he has conducted two Atal FDP Professor Dr. and I got a chance to meet him and personally meet the professor in the field of in person when I went to his campus. So to give his exploration, I got his contact through the faculty development program in Atal. Myself, the introduction. Last year, he has conducted two Atal FDP Professor Dr. and I got a chance to meet him and personally meet the professor in the field of in person when I went to his campus. It is my privilege to give his exploration. I got his contact through the faculty development program in Atal. Myself, the introduction. Last year, he has conducted two Atal FDP Professor Dr. and I got a chance to meet him and personally meet the professor in the field of in person when I went to his campus. It is my privilege to give his exploration. I got his contact through one of the top 2% faculty development scientist as recognized by Stanford University, Scopus. And his distinguished is not the first time, this is the third time he is getting that. His contribution to research and innovation is very much on the fields of the diesel engines, emission control, optimization, and he has been also serving for the teaching and research community since 1994. His outstanding research profile for more than 100 publications in SCA and Scopus Index journals with the H-index of 35 speaks for his superiority over the field. He has completed AICTE-funded research projects and consultancy works. Most of the consultancy works he has got into the field of biodiesel-related things. And he has been also the guest editor for international journals published by InterScience and TransTech publications. His rich experience in organizing and delivering, as I told earlier, the AICTE Adult Faculty Development Program. Apart from that, national workshops and conferences is very important for the field of the biodiesel related and particularly hydrogen fuel alternative related exploration of the fellow research members and scholars. Even the new area of green vehicles, he has taken much efforts into take number of people invited to the forum to research, discuss on hydrogen energy, biofuels, electric and hybrid vehicles, and particularly the sustainable mobility. He has already delivered a number of expert lectures and he has chaired in many technical sessions, national and international level. To add to his vast academic experience, he is also involving actively in the Atal initiatives, and we are very proud to have Dr. Saravanan Subramanian as our resource person for today's FDP session. On behalf of the organizing institution, Welltech Multitech, Dr. Rangarajan, Dr. Shagutala Engineering College, Avadi, I welcome warmly and very respectfully Professor Dr. Saravanan Subramanian, and look forward to an insightful and enriching session from you. Welcome, sir. You can take over the session.
Thank you, Professor Muthukumar, for a nice introduction, and again also inviting me as to deliver a talk in this FDP. I also thank the management and other authorities who have given permit me to take part in this FDP. May I say good morning to all? Good morning.
Good morning, sir.
Good morning. All right, just I'll switch off my camera. Right. So, with respect to this continuation of an introduction, I'll thank Professor Muthukumar and I'll start our technical session. Right. So today we are going to discuss about optimization. So about I'm very unaware about the participants, right? In person, if it is an in person, I will my handling will be something different, right? So it is not it is a narrow-oriented subject. It is a common to all those who are involving in any field of research. We want to do any analysis, any data. The data may be anything. It may be a technical data, it may be an administrative, whatever it may be. Even nowadays, this is a time for elections. So if you have data with different range of data, how to do analysis it, how to get a conclusion of it. That is the major agenda of this session. So don't think it is a narrow kind only for the applicable for a particular research, whether it may be your science or engineering or medicine, or if it is an engineering, whether it is electrical, electronics, whatever it may be. If you have a set of data with the problem statement, so you will analyze the data to get a conclusion. How to conclude it? That is the major thing we are going to see. So at any time, anyone can stop me in between that to have to discussion, to have a confirmation. Don't wait still at the end of the session. In between, at any slide, you can stop me. I'm ready to discuss with you. Right? So everyone is ready. May I start the session? Okay, thank you. So I'll share my screen. Yes. Good morning, participants. Once again, my screen is visible. Please respond.
Yes, sir. Visible.
Yes, sir. Visible, sir.
Please. Thank you. Thank you very much.
Yes, sir. Yes, sir. Visible, sir.
Right. So this is about MRSN optimization using Taguchi design. Now this word Taguchi is a catchy word. It is the order of for any research work everyone doing. And optimization. Each and every field, whatever it may be, we have to do optimization. That is the role of mainly engineering. Science and engineering is doing for it. We need to optimize it. We cannot continuously do anything with it. In this, what is optimization? MRSN optimization, right? How this Taguchi help in this MRSN optimization? So I'm not going to expand this MRSN now. When in the due course of the discussion, then I will explain what is an MRSN, why you are calling this, what is the expansion, everything. And that is Taguchi design. So this MRSN and Taguchi design is a parallel, like a track. So it cannot be separated. So without Taguchi design, without Taguchi help, we cannot do optimization of MRSN. So everything is begin with Taguchi design, right? So what is the Taguchi design we are going to see, right? Can anyone read the slide, please?
Taguchi-based design of experiments, DOE.
Thank you very much. This DOE, design of experiments. This is again the base for Taguchi design. Taguchi is something, design of experiments. Design of experiment is an art, it's a science. Because what we are telling is, when you start to do any work, experimental work, the scientific approach of experimental work is design of experiment. Suppose you say you have a facility to change 3 to 4 factors. by varying these 2 to 3 factors, you can do some experiments on any field. It may be science or engineering or data, whatever, many field. If you are able to vary a factor, particular factor, and you are able to determine the effect of that factor, so you cannot simply proceed with varying the factor again and testing it. First, you need to design it. So by this, the scientific way of designing only will lead optimization properly. Without doing any design, we cannot optimize it. Right? So that is the basics of design of experiments. We need to create a design, like a base. So if we are creating a strong base, you can build n number of buildings. Like that, if you design your experiment, you can do any type of analysis, any kind of analysis you want behind the design of experiments. Next, what is this? That's fine. It is how we are going to conduct the experiment and what way you are going to plan. That is the basics. So as I have told that we have a factor, we have an analysis. So we are giving some inputs, getting some outputs. How the inputs and output has to be related? In what way? Simply by having the mechanism, simply by having the facility, you cannot keep on changing the inputs, you cannot get the output. But there is a correlation between them. So that is the basic step of the planning and conducting and evaluating, right? So again, it starts with objectives and selecting factors. So now I'll come to the objectives next. What is the objective? Because any work, either it may be research work or whatever it may be, that's an objective. Without the objective, we cannot do anything. So how to determine the objective, right? How to fix the objective? On what basis you are going to fix the objective? That is this DOE will give answer for it. So again, that's why the final result. So with the DOE, you have to start the factors, you have to inputs and outputs. Then we have to, what is the effect of this input on the output? How the input is related to the output? What are all, everything we need to analyze it. So that is so for all these things, the design of experiment is the base. Then what is then problem statement? This is a very first step of design of experiments. So without this, we cannot do. What is your problem? I want to control, right? The cost of anything. So I want to control the expenses of my house in a month. That is your problem. I have more expenses in my house in a month. How to control it? So in a particular industry, so the machine wastage is very high. I want to reduce the wastage of a particular product. I want to increase the mileage of a particular vehicle. So these are the problems we are having. So we have to analyze this problem. So your problem statement is you have to very define. Without defining the problem statement, we cannot go further. So based on this problem statement, then we need to fix the objective, everything and all. So by a clear problem statement, will proceed you in a smoother way about the objective. Then n number of problems, whatever may be, right? I want to control my sugar level in my body. That is your problem, right? Then only you can look after the analysis. Then in the problem statement, right? Then what are the ways after determining the problem statement? Then you have to fix the factors. How to analyze them? Suppose I want to decrease the cost of the expenses in my house. This is the objective. Then what are the factors affecting your expenses? Why the expenses of your house is high? Why the wastage of a particular material is high? Why the fuel consumption is very high? So these are the you need to find out the reason for it. So your house expenses are more, right? More expenses on what you call that is a transport expenses are more, food expenses are more. So these are the two reasons house expenses are more. Suppose you are taking your vehicle, where fuel consumption is very high. Why this fuel consumption is very high? right? You are operating in a slow speed. You are operating in a high weight. So this is the reason. So to control your cost, what are the reasons? So that is the next link of URI. Suppose you want to increase why my blood sugar is very high. So you are taken this, you are put the profile is affecting this. You have taken the food at different time. So this is the reason for your problem. So this is the next level. Then only, so you want a solution for it. Then you need a solution. Then you need to get what are all the factors affecting it. So what are all the affecting the transport expenses of in your budget? What are the factors affecting food expenses in a month? That is the factor. So next, now you have to list out the factors. Why your transport expenses are more? What are the factors influencing the transport expenses has to be selected? What are the factors increasing your food expenses has to be selected? What are the factors increasing the material cost, material wastage? Why the material wastage is very high? What are the factors influencing? Like this is now are able to know what is the problem statement you have. So these are the factors, right, affecting your problem. Now you need to analyze the factor. It may be n number of factors, 1, 2, 3, 4, 5, whatever it may be. You have to select all the factors. Then only you need to find a solution. Which factor you are going to change. So that is the very, very basic objective of this problem statement. You need to define the problem. Without knowing the problem statement, it cannot, it is 50%, more than 50% over. We were defining a problem statement. Suppose I want to reduce the machining cost. Right? I want to increase the operating cost. I want to reduce the operating cost. So why the operating cost is more? Why the machining cost is more? You just to influencing. Then determine what are the factors affecting this will include. So that is the basic step in this. So you have to state the steps where you frame the objective. So you can do it. If it is a research point of view, you can get the literature review as a technical point of view. Otherwise, you can get the forecasting data. Right? Suppose now the forecasting data will know the weather conditions. Why the weather condition is this much for they are going for a forecasting data. So from this literature, we have to lay it out. Suppose you want to, what are the operating parameters affecting the performance of the engine? So what are the factors increasing the cost or the wastage of the material? Is there any reported available? What are the factors influencing the wastage? So you have to list out all the factors. So that is the literature review. Then you have to list the literature inferences from the literature review. Then you have to identify your research gap, then possibilities for this research gap, and justifying your identified research, then proposed objective. Now your problem statement is converted into objective. Now I want to affect that. Right? I want to analyze the effect of transport expenses, the effect of what are the factors affecting transport expenses, right, to reduce the monthly expenses of my family. This is your objective. I want to reduce the factors affecting the material wastage to save the material cost of the product. This is your objective. Like this, your problem statement, then your factors, then based on the factors, you need to objective. Now, still now, you don't know what are the analysis every part. Just you are setting the objective only. Now you need to proceed further. This is the first step in your problems. Again and again telling this is applicable for any field. Applicable for any field and anything, anyone can do it. Right? I'm actually, my full screen is presentation. If suppose you are raising hand, I'm not able to do. Suppose you have any queries, you can call. Then, can anyone read the slides, please?
Responses, selection of responses for the chosen objective.
Right. Responses. What are the responses you are going to measure? Right. That's why the factors, the operator, suppose you are telling that the factors affecting the material cost, factor affecting the material wastage, the factors affecting machining, right? So these are the factors. Then what are the responses for the objective? Right. Again, further, if it's a time, suppose if it is a machining time, so time is your response. You are measuring the time. Suppose you are analyzing the material wastage that in terms of weight. So material wastage in weight is your response. Suppose you are calculating the cost, machining cost. So rupees, machining cost is your response. Again, suppose you are operating parameters of that is, suppose you are doing an emission control of your machine or engine. So the emissions are your parameters. Suppose you are taking a quality statements, the quality parameters. What are the different quality parameters you are measuring against the machining? For choosing a particular factor you are introduced, you are determining different quality parameters, whether it is accuracy, whether it is something like that. So these are all the responses. Responses based on the response, that ultimately it has to relate to your objective. So if it's a cost, means it's the final cost. If it's a time, means the final time. Right? So something like that, everything. The quality means accuracy, right? Like that it will go. That is called the responses. So what you are going to measure, that is the final term, right? Final thing, what that is the final, you are going to give an analysis. Suppose your blood pressure or your sugar level, that is the final thing. But you are analyzing some food profile, different food profile will show different blood sugar. So your blood sugar will be your response. Right? Again, blood pressure may be your response. Like this, anything, any field, anything. So number of voters, number of that percentage of votes. So something the percentage, something like anything can be added as a response, right? Then how to, now you have the objective, you have the response. Now how to proceed this, right? That is a flow chart. Very basically, I have told that it is, you are going to start with the problem statement, and you are defining the problem, you are doing the objective. First, you need to select the factors. What are all the factors affecting this? Suppose factors affecting your transport expenses, factor expenses, your food expenses, factor, suppose transport expenses, so more family functions or more, right, more outings, right, something like that, anything. So what are the factors? So suppose you are machining, means that is an undisturbed machining, right? The quality of the material, right? The quality of the cutting tool. Like this, you can have the factors, any selector, what we call the cutting flow, that is a machining speed, machining material. Like this, any factors you are affecting the final, whatever your objective, you need to list out the factors. That factors has a direct influence on the response. By choosing a different cutting tool material, you are finishing, the quality of the material will affect. So there should be direct link. There should, indirect factors cannot be taken as a factors. So it should have a direct link. So choosing different material, different cutting tool, right? Different time. So that is the factors. All right. So like this, you have to, any factors affecting the responses has to be chosen. Then levels. The same factor can be tested in different levels. That means, suppose a material plays a major role in determining the accuracy or finishing. So you need to do different materials. A role means you have to choose different cutting time. Suppose speed affecting a particular part means you have to choose a different speed. Suppose if you go in any molecular level, so concentration of a particular chemical is playing a major role, means we have to choose a different concentration. Suppose a chemical itself plays a major role, means you have to choose different chemical. If a chemical is a factor, you have to choose different chemical. If a concentration of the chemical is a factor, you have to choose the chemical with a different concentration. Same chemical, different concentration. Like this, suppose speed means different speeds. Like this particular factor, which is a factor, which is a level, that you need to select levels, because more levels will give more accurate. Right? Oh, selection of the appropriate orthogonal array. What do you mean with this orthogonal array? That means suppose you are choosing a 3 factors, 1, 2, 3. Each factor having 3 levels. So you need to test 3 into 3 into 3. 27 combinations you need to test. 27 combination, because of you are testing 3 factors and 3 levels. So if suppose the more levels, 4 to the power 3. If 5 levels, 5 to the power 3. Suppose if there are 6 factors, 3 levels, 3 to the power 6. Like this, the number of combinations will be getting increased with with the increasing factors and levels. Which increasing more factors, more levels, your analysis, your predictions will be accurate. So that in that case, you don't want to get analyze all the combination. You have to save the time and energy. You have to come to a conclusion with less number of combination. Then you have to orthogonal array will help you to reduce the number of experiments. That is the orthogonal array. Then that orthogonal array, whatever factors you have chosen, you have to fix into the column. I will explain. Then you have to do experimentation. Then you need to analyze it. That is optimization. Then after analyzation, you need to conform it. Selection. Right? So the factors affecting the responses have to be selected. It has to be based on, as already told you, it is based on your forecasting or literature or your own experience, but you have to justify why you have chosen this plus. Without justification, you cannot simply add the fact, whether that factor has a direct influence or not. By having food at a different time, right? My sugar level is varied. This is a known factor. It's a link. Someone already reported that, right? Adding food from morning, instead of 6 a.m. to 8 a.m., blood sugar was affected. So it is reported. So you have to take this as your value. So by operating the engine with the different speed, by increasing the speed, by consumption was lower, reported, already reported, available. You have to take this. So by decreasing the cutting rate, so the cost was increased or decreased. So someone has already reported. You have to take that. So a factor which have proved response, that is the influence has to be chosen. Right? Then only you have to come to a conclusion. Then based on literature, or it has to be selected. Then it is again factor 1, factor 2, factor 3. It depends on n number of, you can choose any number of factors. If you have more number of factors, you can choose more number of factors. Accordingly, you can do test. If it is an experimentation, that much combination you need to test. That you need to fix it. Then again, I will tell you number of levels. So for one factor, you have to choose more number of levels will again increase the accuracy. Suppose you are a minimum and maximum. So standard or what you call the base 0. It is called the minimum level. Maximum level, so whatever it may be, you have to fix it. Right? More level desirable for each factor. Critically, your analysis will be critical. Minimum 3 levels will be an optimum. If you do less than 3, there is no meaning of testing. Right? You have to do minimum 3 levels. So again, the levels of the factors. Again, minimum to maximum value you have to fix. For each things, you need to justification. Proper justification. What is the minimum value? What is the maximum value? How do you fix the minimum value? Suppose cutting rate you are fixing means what is the minimum cutting rate you have fixed? What is the maximum cutting rate? Speed, minimum speed, maximum speed. Right? So suppose sometimes this minimum can be a 0 or standard value. Suppose you are to suppose for a particular pressure or something timing, right? A standard value will be there. whether it may increase or decrease, you want to analyze. But a standard value, you can check there's a minimum level or the base level, or sometimes zero. Suppose you are increasing some percentage, right? So you can sometimes zero, that may be minimum level. So the fixing the maximum level will be the major challenge for you. That maximum level you can fix based on literature, because you cannot keep on increasing the maximum level also. There is some limit because side effects will be there. But definitely there will be side effect. So definitely, so based on that maximum. So between the minimum and maximum, you can fix any intermediate level. That is a level. Suppose 0 or 10 is minimum and maximum, means you can fix 3 levels. No, I want to fix this more. Then 0, 3, 9, 0, 3, 6, 10. Right? So 0, 4, right? 8, 10. So some I want to more 0, 2, 4, 6, 8, 10, like this. So you can increase the level to analyze the critical point. So first thing is you have to fix the minimum and maximum. Then only if you fix this minimum and maximum levels, in between level, you can choose it arbitrary based on the data. So justification through inferences is very, very important, because the research itself, you need to justify it. Without justification, we can't do anything. So you need to first, right? You have to proper literature support or any other proven record must be there. That is the justification. So if you have 3 factors with 3 levels, so these is you have to a combination. Suppose this has a 3, for example, injection timing, EGR, injection pressure. This is the inputs. Suppose timing means it is measured in angle, or sometimes it may be, suppose you are measuring timings in terms of seconds, right? EGR means it's a percentage. Sometimes it may be weight. Suppose you are doing, it is a weight kg. Injection pressure, unit of the pressure, right? It's a Pascal or bar or something like that. So that is the levels we are having. So how many levels? That is you can having different angles. That is the levels. You can have different percentage. You can have different pressure. That is the levels. What is the response we are going to measure? For this particular, it may be emission. It's a emission and performance is the response. That finally it may be cost, right? Savings, time, right? Something that are the responses outcome you are going to measure. So after confirming this factors and levels, you need to table this, frame a table like this. What are the factors 1 to 3? What are the levels of the factor? This is very basic step to proceed further, right? Then factors with their levels. Then you go for, as I told you, factorial design. That's why orthogonal array. In the orthogonal array, as I told you, if you want to increase the, to get the conclusion with less number of experiments, you have to go for orthogonal array. Right? That's why I told you, if you have under 3 factors, you need a 27 combination. It is a full factorial design. If you are going for a 3 factors, 3 level, 27 combination, it is full factorial design. Now, you want to reduce a partial or a that is a partial design, then the number of experiments will get reduced. Validity, implementation, cost, and time constraints, you have factorial design. 2 or more factors, each of which has 1 or more 2 levels, right? Full factorial designs include all the possible combination levels across the factors considered. That is a full factorial design. If it is a partial array, L8, based on the number of, it depends on the number of levels and factors it is suggested, right? You cannot, suppose for your, suppose selecting more number of factors with less number of experiments is not advisable. You should not do like this. So this is a kind of array for 18. Array with again 8 factors. You see, there are 8 factors. F1, F2, F3 are factors, and suppose F1 factor only 2 levels, other factors are 3 levels. So this is a sample of array 18 trials. If it is a 8 factors and with 3 levels means, so the number of combinations will be around the 600 to 700, right? So this within this 18 experiments, you can get a conclusion. This is the importance of orthogonal array. So factor assignment to column. That's why earlier you have chosen. Suppose you see this is the factor you have chosen. 3 factors and 3 levels. So these 3 factors and 3 levels, as suppose if it's a 8 factors and 3 levels, these factors and levels has to be fitted here. By fitting this, based on this, you have to conduct the experiment. Suppose each column has to be designed for a factor. So based on this, we have to prepare a test matrix. That's it. You see, this is. So this is for a 3 factor, 3 levels. Suppose column 1 is for a first factor, column 2 second factor, column 3 third factor. So this is levels: first factor, second factor, third factor. This is first factor, second factor, third factor, like this. Here it is 1, 1, 1. So the order will be different. So first factor will be injection timing, second factor will be percentage EGR, third factor will be injection pressure. Accordingly, this is a 3 factor, 3 levels with only 9 combinations. So instead of 27, you may conclude with this 27 combination of experiment, right? So testing, after this you have to conduct 9 testing. It may be anything. Again, as I already told you, it may be based on factors and levels. These are the combination. For suppose for first trial, 23.4, 0 and 210. That is the combination. So it depends on your factor, it will vary. So this much of cutting rate, this much of cutting speed with this material. Like this. Like this, it will vary. So you have to conduct test with this 9 combination. While conducting test, you should not start from 1 to 9 or 9 to 1. You have to start somewhere middle. Because to get the factor effects quickly, very effectively, so you have to start with the random order. You have to go a zigzag manner. Anyway, anytime you can test. You should not start from 1 to 9 or 9 to 1. A random order has to be followed. And each trial has to be tested twice minimum to get the repeatability of the experiments. Right? Each factor, each trial has to be tested twice. That is called replicates. But every time you have to measure the responses. So the average of the responses you have to take. Suppose you are measuring the response. Suppose you are measuring the cutting time. Measuring time means, so first combination you are measuring as 10.9 seconds. So second 10.8, third 10.9. So three times you are measuring means, so average of these 3 will be your actual measuring time. Like this we have to. Then we are coming for analysis. Right? Shall we proceed? Shall we proceed, participants?
Yes, sir.
Please.
Analysis of results, sir.
Results. Thank you. Thank you very much. And that is coming for MRSN optimization. So now you have had your responses. Whatever it may be, one single response or 2 response or 3 response. It may be anything. Responses may be n number, right? So the responses, you have got the responses. Now the responses have to be optimized. Again, this optimization is multi-objective optimization. Right? So the multi-objective optimization, for example, I'll tell very simple because our day-to-day life is simple. Suppose you are going for a food for a hotel. So while the considering factor is the cost of the food at the same time, what is the other factor? While you're taking food in a hotel, the cost of the food, other thing is what? What do you consider? Any reply? While taking food in a hotel, so cost is a one factor. What is the other factor?
Taste, service.
Taste. Then?
Service.
Pardon?
Service.
Good.
Ambience.
Ambience. Excellent. Hygienic.
Yes, sir. Hygiene. Yes.
Right? So, you see, these are all, so you want to, what is the thing? So, cost, hygiene, taste. will take this as 3. So you need to optimize these 3. Definitely, suppose the cost and hygiene, right? When the cost is low, hygiene will be, it is directly related, right? The cost is high, hygiene is high. Say yes or no?
Yes, sir.
Something like that.
Maybe.
Like this, these are the directly related factors. Or sometimes the right. So right, when the cost is very low, right? So taste may when the you should not get the low cost food. It may not be hygienic. So while deciding this, you need to get the cost, hygienic, taste, and everything you have to consider. So that is the multi-objective. You cannot select only cost alone. You cannot take hygiene alone. You cannot take the taste alone. So when multiple factors are involved in particular selection, right? Suppose choosing a movie, you are taking a song, you are taking a fight, you are taking a comedy, you are seeing the actor. You see, these are the multiple things you are selecting. So how to get it? Which is more thing? So that is called multi-objective optimization. You have to give preferences to each and everything, which is first preference has to be given. So that is called optimization technique. Suppose there is no other way. I need only a cost is my factor. So wherever the cost is high, I will go. That is only one objective. Your objective is only one. But that is right. When you go for anything, so you have to get the quality as well as cost. Because by buying a material, you are seeing the quality as well as material, life and cost. Suppose you are buying a television or something like that. What is the life of the TV? What is the cost of the TV? It is inversely proportional. So like this, you have to, what is your objective? Whether you are going for a single objective or multiple objective. So that is that things. So you have to consider all these things. Then you need to take a result. That is a multi-objective. So our main aim is when the responses are more, like as you say, if it's only one response, there is no analysis, there is no optimization, right? Straight away you can proceed further. You need not worry about any engineering, no technology is available. Your option is only one, go away. But engineering is not like that, right? You have to consider so many factors, so many things. We cannot decide a simple thing. With a single thing, we cannot decide anything. There are a lot of things, starting from selection of a bride, groom, and brides. We are seeing so many options. There are so many constraints. Like this research also, we need to multiple objective, right? Several conflicting objectives into consideration simultaneously. You need to get this simultaneous. That is, now it is ready to get multi-response signal to noise ratio. This is called immersive. When the response is only one, right? There is no, right? It's a single response. So what is the signal? What is the noise? Whatever responses you are measuring is the signal. Say you are measuring the machining cost, you are measuring the machining time, right? You are selecting a material, you are measuring the speed. That is a signal. Then what is the noise? Whatever disturbance you have observed during this measurement of these responses is noise. Suppose you are measuring speed in a tachometer, right? The repeatability of the tachometer, accuracy of the tachometer is a noise. Suppose you are measuring the temperature, your ambience is your noise. The sensitivity of the instrument is your noise. The repetitivity of the instrument is your noise. Like this, whatever parameters which is affecting responses, right, is your noise. So you are measuring the signal to the noise. When the noise is less, signal value will be good. Because signal to noise, right? So multi-responses means when the responses are more, it is called multiple response. That is called, it is MRSN. Ratio is separate. MRSN ratio. MRSN will not give any value. It is a multi-response signal to noise. That's all. It has to be given ratio. MRSN ratio. Right? First, start with loss function. What do you mean by loss function? Suppose you are measuring, right? You are measuring anything. What is the loss in it? What is the loss in it? Suppose you are measuring the efficiency. You are measuring efficiency 30%. What is the loss? Anyone? Your efficiency is 30%. What is the loss?
70%.
Pardon? 70. Excellent. Good. That is, what is the loss function means? What is your target? What is your target? Suppose you are measuring your expenses is 100 rupees. What is the loss? Loss function. Anyone? Your expenses is 100 rupees. What is the loss?
Our salary.
Pardon? What is your objective in expenses?
Within our salary limit.
Whatever, the salary will be different. Ultimately, what is your objective in your expenses? Maybe can you take 0? I don't want X. That is your ultimate ideal thing. So your 100 is nice. Your 100 itself is nice. Sorry, last one. Because when you are minimizing something, 0 is the minimize. Maximum is maximum value 100 or infinity anything. That is when you are minimizing means the lowest value is 0. Right?
Yes, sir.
So that's why this loss function. So what is you have achieved and what is your target? That is the loss function. Target values of the responses and the measured value of the responses. Suppose you are measuring emission. You are measuring the carbon dioxide, carbon monoxide. Your ultimate aim is to 0 the emission. So 0 is the target. Suppose we are measuring the efficiency. Suppose your income, right? Your income is the response. Maximum infinity is your target. Like this, you have to maximization. Whether you have to particular loss is to be maximized or minimized. If it's a profit, it is maximized. Loss, it should be minimized. Right? So, suppose measuring time should be minimized. Measuring cost to be minimized. Like this, number of products produced, maximized. Like this, loss function will be based on what is your target, whether you are going to maximize or minimize. That is a loss function. So each and everything, right, you need to first convert into loss function. So this is the loss function. Whether you are maximizing or minimizing. You maximize panna poringla, minimize panna poringla. So that is why I'm telling is you are measuring so many responses, right? And so many replicates. Over replicates ko tanitaniya edukring, right? Suppose a particular means suppose each trial you are testing with a different 2 to 3, right? So for everything you need to calculate. So that is the larger the better. That is yi is your response, right? How many, right? Levels, each factor at different levels, right? And how many of your repetition you have done, everything that is based on this, larger the better. When it's a smaller, it is different. Break the efficiency and all maximized and the emissions should be minimized, right? It is a first thing of your loss function, of a particular response at a particular level, right? Then again, when multiple factors are involved, suppose you are telling that you are measuring the quality of the food, taste, right, ambience, and the cost. Hygienity, So cost is measured with respect to the machining time. It is in second. Machining cost is in rupees, right? Material weight is in kg. So these three are different units, but these three are the common. If your responses of a particular investigation or a particular investigation, if these three are the responses, you need to get a common factor, normalized value of all these three. That is called the normalization. Right? What do you mean by this? Means you have to convert this into greater than 0, less than 1 to get a common thing. That is the normalization. So that is again, it is a minimize or maximize. So suppose you have a 19, suppose a number of trials, 18 or 9 or 10. So each right response of the trial is divided. We have to take the minimum value, and from that, with the use of the minimum value, you have to divide it. So for particular thing, it will get 1. Other thing, you will get a 0 value. So that is greater than, that is a less than 1 value. So minimum of this under each factor. Again, if it's you are maximizing it, you have to divide that value with the maximum of that value. Our aim is to get the decimal value. You have to get the value between greater than 0, less than 1. Decimal values. That is the normalizing. Then again, weighing factors. Again, another important thing, weighing factors. Which is most important? You are choosing a factor, right? Choosing a film, right? You are choosing songs, fight, right? Comedy. So, which is you are giving most preference? I can give comedy is the most preference. Someone give fight is the most preference. Someone give songs is the major preference. But like this, when 3 more than responses are available, which responses you are giving most preference? Or are giving equal preference to all? Suppose for a material cost, the material cost, machining time. So which factor you are giving more weightage? Right, machining time, machining speed. So like this, you have to give a weighing factor. So depends on this weighing factor plays a major role. By choosing this based on this weighing factor will be your final results will get applied. Right? So by change, you can change this weighing factor to get a different result. Right? So that is the weighing factor. So like this, you can choose between greater than 0, less than 1. Anything, any combination. But if you add, it has to come 1. Suppose if you take 0.4, 0.4, 0.2, 0.6, 0.2, 0.2, 0.5, 0.25, 0.25. Suppose we have 5 factors, each factor is 0.2, 0.2, 0.2. You are giving equal importance. Suppose you are having 3 factors, right? You are giving maximum weightage to one factor, 0.7, right? Remaining 0.1 by 0.5. So you are giving 70% weightage to one response. The remaining are less. Like this, you can give. That is the weighing factor. I'll give the table again, while results. So by including this, you already have a normalized loss function. By adding this weighing factor for each that responses, you can get a total loss function of a particular trial. I'll give a table, model table, right? Then it will be clear for you. Then now you get the, after weighing factors, you got a total loss function, right? So from this, you can get it the ratio, MRSN ratio. You have got the total loss function. From this total loss function, you can get the MRSN ratio, multi-response signal to noise ratio. It's a 10, it's nothing but a numerical. You can have it or not having, no issue. It's a 10 log TL by J. This is, you have got the MRSN ratio for whatever trials you have tested. How many trials? It's the 9 trial, 18 trial. For all the 9 or 18 trials, you get the MRSN ratio. You see, this is the table. You see, these are the loss functions. So this is a normalized between, right? You see, any one factor is 1, other factors are less than 1. So you have given weightage. Suppose whatever weightage is actually multiplied is a weighing. If you add all these 3, this is total loss function, then it is MRSN ratio. So you are getting 9 MRSN ratio. Then what is the results you are getting to get? The MRSN ratio which having the maximum value will be the best. Why I have to choose maximum value? Any idea? Among this MRSN ratio, the maximum MRSN ratio will be the best. It's just a mathematics. Can anyone tell why I have to choose? We have to choose maximum MRSN ratio. Any idea? It's a signal to noise, because as I already told you, the responses are signals, right? So noises are the factors that is affecting it. So wherever the noise is low, signals will be high. So that's why it should be maximum. So MRSN table, we have the maximum MRSN ratio has to be chosen. Then we need to, as per this, this combination is the optimum combination. Whatever the combination of the factors 7 will be the optimum. Again, this is not final. Still, it has to be analyzed further. That is called a factor effect. That's why we are going for a Taguchi parametric design. Taguchi parametric design, nothing but, so this MRSN ratio will be further analyzed. Suppose you are taking each, right, what you call each trial as different combination of factors. So each factor, the levels of the factor values has to be average. Suppose, for example, suppose you are choosing a particular level, means sum of MRSN ratio of the factor at the level you have to choose. You have to sum it and divide it by the number of levels. For example, I will show a table. Then it will be easy for you to understand. Suppose you have got this is 9. So suppose you are the first level of injection timing, right? You are analyzing the first MRSN ratio, 9 MRSN ratio, got it. So the first 3 as the first level. The first 3 MRSN ratio has to be average. That is the average for the first level. The second, this average of this MRSN ratio will give the second level. Third, if we go for column 2, 1, wherever the 1, that MRSN ratio has to be average. Wherever 2, that MRSN has to be average. Like this, if you get the average MRSN ratio, right? So you will get level 1, level 2, level 3. So the level which has maximum value will be the best level. You see, 0.26 will be the best level, 0.48 will be the best level, and 0.26 will be the again best level. So this combination will be the best combination. Combination, this factor of this level, this factor of this level, this factor of this level will be the optimum combination for your problem statement, whatever you have decided. Then this has to be, again, we have tested multiple factors. Which factor has more important? You are taking 5 factors, right? So which factor I have to concentrate? Which factor is more influence? Whether it's particular factor is not influence or not. For that, we are going for ANOVA. This variance has to be analyzed. Analysis of variance. This is one important tool. So by analyzing this variance, you can list out the percentage influence of the each factor. Each factor, how it contributes. From this, which factor has more confidence, which factor has less confidence can be identified. This is ANOVA table. You see, suppose this is a sum of square factor. Each factor has its own sum of square. Again, this will be from this MRSN table and error. So there is a total, you will get a total value and the individual sum of values. The difference between these two will be the error value. Degrees of freedom. Suppose number of levels 3 means degrees of freedom will be 2. Again, total test is 9. So degrees of freedom is 8. So that means the error degrees of freedom also will be 2. It's the mean square factor. It's nothing but it is the sum of square divided by degrees of freedom. This is called. What do you mean by this percentage in influence means percentage the individual sum of square divided by total sum of square. That is the percentage influence for that particular factor. You see, 66% is influenced by this first factor, and 19% is influenced by the second factor, and 8% is influenced by the third factor. So the error as a 6%. That means for this combination of testing, the first factor is a maximum influence. So this is the most influencing factor for this, followed by injection pressure, followed by the third factor. Suppose sometimes your error contribution is more. Suppose the noises of your experimentation is more. You need to properly address it. Maybe you need to repeat it to reduce this noise level. The repeatability of the instruments, the ambience, atmosphere, right? The sensitivity, right? And accuracy and everything, right? Testing conditions is when the testing conditions are more, your error will be high, right? So that is the condition of the ANOVA. So from this, you can get the maximum influence. So by doing this MRSN analysis, you will get the optimum combination. Here, what is that? Whatever factors you are testing, you can get the optimum combination of factors. Then, among the factors, which factor is more influencing and thing. And again, all these are subjected to change. This combination and this influence are subjected to change with respect to this weighing factor. That's why I told you earlier, weighing factor. What weighing factor you are choosing? Suppose you are using 0.4, 0.3, 0.3, right? If you're choosing different weighing factor, you will get different optimum levels. May not be, suppose till now, till this, the optimum factor level is not affected. So by changing this, right? So that means you are increasing the weightage for response 1, your optimum factor is responded, changed. You see, the second factor is not at all changing with respect to this weighing factor. That is one of the important observation. You see, whatever maybe they're changing in the importance, the levels of second factor is not changing. And again, the levels of first factor is also not changing. The only factor changing is the third. Again, the influence, you see, by this level, if you are using this combination, this factor is more influence. But if you are doing this combination, this influence is getting reduced. So to analyze this response, this factor is very, very important. Like this. So you want to analyze this response, your factor influence is this. Because by varying this, you get more influences here. So here, this is influencing. So which factor is influencing on the responses can be identified by this weighing factor. One of the important observation and analysis with this MRSN ratio. Again, this is one of the limitation also of MRSN because of the factors are subjected to weighing factor. Sorry, the results are subjected to the weighing the amount of weighing factor you are fixing. By changing the weighing factor, your results also changing. That is the advantage. That is also a limitation, right? So we are getting some, say 1, 2, 3, 1, 2, 3 or something optimum combination. You need to confirm it. If this is not part of your orthogonal array, whatever combination you are getting is a part of the orthogonal array, you can proceed with. If it is not part of your orthogonal array, you need to repeat it. You have to test this experiment again to confirm this is your optimum combination of tests, right? So this is our MRSN optimization and design. So whatever, right? Any clarification queries? I'm ready to answer. Please.
Participants, anybody have questions, can put it in the chat box also.
Any questions in chat box?
Sir, shall I take the presentation mode from
Yes, sir.
you, sir?
I'll send it, sir.
Yes, sir.
I'll send to you, sir.
To put the poster of yourself, sir, or the event poster.
Sir, Dr. Muthukumar, sir.
Yes.
Dr. Muthukumar, sir.
Sir, on behalf of the faculty members, can I ask one question, sir?
Yes, sir. Please, sir. Please.
Yes, sir. Sir, this topic of design optimization,
Yes, sir.
how it is going to be useful for current trend of research together with the AI capabilities, sir?
Sir, that's why, sir, I'll clear. Cover any fact, any type of research, this topic is chosen. Suppose you have not at all, you don't have any experiment, but we have a set of values. That values has to be arranged with some factors and levels. Suppose you have a 3 factors and 3 levels, means you have to at least 9 combinations. Otherwise, if you have a 27 combinations, you can analyze it. You can have a detailed program it. It is there are a lot of programs are available, but you can do it your own with using Excel or anything. Right? If you have the data, final values will be you can as a program itself, as an Excel sheet itself, we can do by changing the factor levels, by changing the what I call the weighing factor. You can analyze it. That is important. So not at all for any field. The single field you can apply it for any field, but only thing is this data has to be formally structured. Suppose a particular factor is available, means you have to choose the factors with the different levels. The data should be available for the combination of factor levels as suggested by the orthogonal array. If it is a limited value, it has to be chosen by the orthogonal array. If it is full factorial, you have all values. So any missing data, you can collect it. So there should be a particular order is available. If you are able to arrange the data as per the structure, you can analyze it. That is the application and the flexibility of this MRS. Not all for engineering, any social media. So any if it is a factor has to be arranged as the structure. That's all. If it's a 1 factor, 2 levels, 3 factor, 3 levels. The factors and the levels is very, very important. If you are able to analyze this, give the data with the, based on this combination, that is the success of MRS. Hope, are we clear, sir?
Very, very clear, sir.
Right.
Even you have given good answer for combining all the aspects of the slides you have presented. So is there any other questions from the audience? You can post it in the chat box I have posted.
Thank you, sir. Thank you very much.
Yes, sir. Yes, sir. Thank you. Thank you.
So
very
I
much, sir.
thank
think,
Professor.
They will get in touch with you also if they have any technical doubts.
Definitely, sir.
and,
Please.
regarding research. So can you share your credentials or can I share to the people over here if they
Yes, sir.
wanted to contact you over mail or?
Yes, sir, definitely, sir. You have my mail ID, sir. You have my phone number. Please
Yes,
share.
sir, I have, sir.
Knowledge.
I have.
I am ready to share the knowledge. Right. That is our major, our profession itself in knowledge sharing. So now I am very much interested in knowledge sharing.
Yes, sir.
So I thank Professor Muthukumar and his team, right? And personally, Professor Muthukumar sir, for inviting me as an expert member for this faculty development program. And also I thank the management of the college for permitting and approving me as an expert member, right, for this FDP. So I think I have delivered something. For any doubt as raised by Professor, so I'm ready to answer at any time. So please feel free. Thank you, Bruce.
Thank you, sir. Thank you, sir. It's officially it's our privilege to have you. Even you can have direct interaction with the faculty members. Much of the faculty members are doing research on the biodiesel-based trans esterification and even this whatever FDP we attended at your campus, hydrogen fuel-based explorations on this. So your presence in our campus will be much more beneficial to our faculty members.
We'll meet you, sir.
Thank you, sir. Thank you very much,
Thank
sir.
you. Thank you very much. May I leave, sir?
Yes, sir. Yes, sir. Yeah.
Thank you.
The
Thank
expert
you.
member may
Thank you all.
leave the meeting, sir. Others, please stay.
Okay. Thank you.
Thank you, sir. Audience over here, there is a feedback link that will be provided later, not during this meeting. So take note of this. The meeting link, will not be provided right now. The feedback link will be provided later in the afternoon meeting, which is going to happen in the 2 p.m. session. Like yesterday, we are starting today's session a little late. Actually, the daily time is only 1 p.m. Because of the time adjustment of the people, we wanted to take the session in the afternoon itself. So we wanted to keep it before 3:30 so that all others can have a good interaction with the speaker. So today's speaker is Professor Dr. Adam Khan from Kalasalingam Academy of Research, which is in Srivillipudur. So he is going to deliver a wonderful lecture on the aspect of biomaterial and its characterization. Even he will touch upon the topics of degradation and characterization related to the existing materials. So it will be again a re-entry into the yesterday's topic of biomaterials. So if any of the participants, if they want any adjustment towards the